Hi everyone, this video is meant to build a word-to-vec model using GenSim. Let me show you my data file first. It's not that huge and it contains only 21 statements, so you can say it won't have many different words. Now if I start running this to build my model, you can see this section on the right bottom pane. You can see the difference between these two before processing and after processing. Also, I have used the same model here to find the most similar words for king in line number 84, and you can see the output over here, the most similar words for king. This result will change from my model to any other model because the data set used for building the model would vary. So if you have a different data set, then your model will be different, and you can change your hyperparameters to have a different model, and you can see the different values. For example, for George, I have 0.996420. This value will change if you change the epoch, let's say to 200, and I'm running it, so this model will be overwritten, and you can see this is now changed to 0.98 something. So it will be changing based on that hyperparameters data set. There are multiple different things which affect my model and the output. Now I will be going to the next one where I'll be building the embeddings using the same model, same word-to-vec model here. Let me go to the next one. In this, I'm building the word embeddings for visualization. I have disabled the eager execution in line number 65. If you look at this, I have disabled the eager execution because it is enabled by default in TensorFlow 2.0. This is TF compat v1 disable eager execution. If you're using TensorFlow 1, this will be different. This may be, you can find it directly TF dot disable eager execution. So there is a lot of difference between TensorFlow 1 to TensorFlow 2.2 to 2.0 because the packages are changed and they are moved from the core ones. Now, if you look at the line number 66, I have created a session object and calling the run function by initializing the global variables in line number 71. Now let's run this and visualize using Tensorboard. So as soon as I started, you can see I can see my output. Now if I go to the command prompt and let me activate source, activate text analysis, let me go to the directory cd papa/tl and then projects text analysis. As soon as I run this program, you can see there is a projections directory created. I have a checkpoint file created here, and I have model.ckpt. If you look at that, then I'm saving the projector into that, and those files have data from this to this, index and meta file. Now let's go back to the command prompt again and start the Tensorboard. Now here I'm starting Tensorboard with log directory projections on port number 8000. If I run this, it will start and it will show you that it's running. Yeah. So Tensorboard this, add this, it's running now. If I go to my browser and if I run this, you can see the embeddings being shown here. And if you go down to the projector, you can see how your embeddings are being shown. Number of tensors 125 do not match the number of lines in metadata 277, because if you look at this checkpoint projection model, CKPT 277 is being used, and there's a little bit of difference. I will explain that in the next one. If you want to search for any of the word, for example, as we see the most similar word was king, and if I'm searching for king, you can see SQ America, People's Bay, officially kingdom words. So these are the words that are the closest to king, right? And if you want to go for more number of neighbors, you can increase the number of neighbors here, and we'll start plotting all the farthest points. You can see like these are the farthest, and all the points will be activated in these region. Now if you want to visualize the t-SNE one, so it has already started and it's on different iterations. For example, I stop it here. You can see on iteration 181. So you're ideally trying to reduce the dimensionality of so these words are represented by vectors, and you are trying to bring them into 3 dimension. That's it. So while you are trying to do that, you can see all the vectors at different distance. If you want to search for your word king here, then it's here. Now if you want to go for further iterations, then they may move from each other and you can see something else. Now if you stop doing spherized data, then you will see like this. If you activate this, it will be showing you like this. Now if you go for custom, and for example you are searching for a word king, and you can move the cursor like this and you can see all the words. Now let's go back and see how does it look like in terms of embeddings here. So these are the embeddings created, and you can see all the embeddings. Sorry. So these are the neurons you can see, and you can understand all the legends from here. What are they explaining, and how it is building. Thanks for watching, and I'll share the code soon for reference. Thank you very much.